Greetings, everyone. Thank you to David Johnston for reaching out to us to have MaidSafe, myself, to be here to give everyone an update on, I guess, the way that the MaidSafe core development has been going. So I would start with my involvement with the project Safe, let's put it this way. I reached out to David Irvine in June. He posted a problem called proof of human. So I had the idea to, in a video game, when you access the game, you have to finish a tutorial before you can start playing the game with all the other players. So that was a way to prevent people from making too many accounts, because it takes time to finish the tutorial. And the tutorial is so dynamic that you can't make a robot to do it. It's just not possible. So maybe the account creation mechanism will require you to play a tutorial game to enter, right? That's not the case at the moment. But I'll give you an update of the core development process that's been going on at the MaidSafe headquarters in Troon and abroad. Because I guess about a year ago, in fact, MaidSafe, David Irvine, the founder of MaidSafe, Nick Lambert, the chief operating officer, they were here, and they were giving a talk about their idea of a decentralized, autonomous internetworking system. So when that happened, the crowd sale took place. About $8 million was raised in about 5 hours. So that was very impressive. What did that do? That allowed that David Irvine and the gang at MaidSafe over in Troon, Scotland, can now expand and start getting into the implementation. So before this was months and months of lots of work and testing and proving of thousands of pages of concepts. And so here we are now, 11 months later, with implementation. 11 months of implementation. So at the moment, what we have is like a completely autonomous network that was proven in October in a testnet number 2. In the testnet number 3, which in about a week, we'll be looking into the API that Lee Clagett is preparing for us. And in this test network number 3, we'll be able to log in, put a data, pull that data, and interpret that data. So what does that allow us to do? We can make applications on that system. And that system's fully autonomous, mathematically proven by the nodes themselves on the network. So the way that the network is designed is that you have a node that can only do a certain set of mathematical things. So therefore, that node is always trusted. So because it could only do a certain amount of mathematical processes, let's say. So for example, taking a piece of data, storing that piece of data, checking if that data is valid on a regular basis, doing safe coins, making sure those safe coins are valid on a regular basis. So that allows us to do many interesting and novel things. It lets us make trustless, decentralized systems in the way that, let's say, traditional, let's say Bitcoin, for example. We're here about Bitcoin. Bitcoin blockchains, they're slow, but they were made in 2009. They are not meant to process, millions of things at one shot. They're meant to process just only that blockchain. So MaidSafe, what they've been brewing up, we have now the ability to put a piece of data, process any kind of data type on this network. And what that allows us to do, for example, we can make a reader we can interpret any kind of text, for example. So if there's news articles, you can read those news articles, and you can test those news articles against other news articles, for example. So we can now have federated news and make sure that one person's information is kind of close to another person's information, for example, like that. In fact, we created this startup out of San Francisco, and that startup out of San Francisco, we designed financial information exchange. We took that, made it into a JSON format, and allow now for people to take a message and send that message to another client, and that client will interpret that message, and in that message can be a financial information. So take financial information, replace it with research, replace research with news footage, replace news footage with whatever you can think of that is valuable to a person. And you can now share that with people, send coins that require no fee. You can trade coins that require no fee. You can reach out to other networks like Bitcoin from the Safe network. You can store data. You can reference that data anytime. So a little more from David Irvine. He got back into the code in November. So there's a very robust development team. In November, he took it upon himself to start re-implementing many things. So about a year ago, 11 months ago, we were expecting the Safe network probably to be live and running and kicking by fourth quarter of December. However, when David Irvine got back into the core development in November, he noticed and thought about many, many fundamental things in terms of robustness of this network. So in that process, he took it upon himself to realize that there's more to do than there's more that can be done with this network than just data storage, for example. So the fact that you can, to process infinite amounts of data, for example, something we go into the API about is like you store a 1 megabyte piece of a file. So if you have 1,000 gigabytes, 1,000 megabytes, which is a gigabyte, and you put each one of those megabytes, they go on a separate computer. They're not on one server. So when you want that 1 gigabyte back, you're not asking one place for the 1 gigabyte. You're asking 1,000 places for 1 megabyte. Actually, you're asking 4,000 places for 1 megabyte. So whoever gets back to you first, you could get that 1 gigabyte instantly. Because how long does it take to get 1 megabyte from a computer? So you could get 100 terabytes instantly if you have the bandwidth to handle that kind of transaction. So it's been really rigorous. The code base in December and January has been refactored down. The figure is 70%, but what does it matter? As a developer, what matters the most is that you have a vault with simple parameters there. So what does that mean? We can make an API that's so simple that's put, get, update, and delete. Actually, data is never deleted. You can always reference the same file all the time. So what else can we do? It's up to everyone to determine what they want to do. I would say it's been a tremendous endeavor to develop this network. In about 3 weeks, something like this, we can try out this network as a whole. We've already, as the Infinity Algorithms, a company that I started, a company that I started around the Safe network to build something for the Safe network, to, let's say, prove the business model of the Safe network. We created what's called Safex. So I guess my slides were gone through instead of my clicking, or maybe I pushed with my, but either way. So you see, the stack is kind of like this. You have the Safe network, right? That's on the bottom. So the Safe network is your autonomous entity that processes everything you could ever want to process in a total real time. So whatever you push to that network, you can get back. Anyone can get back because it's free. So what we have is a protocol, a Safex protocol, which is based on a financial information exchange protocol. That has been working for the last 23 years for financial institutions. And so we re-implemented that with a JSON format, and we gave it tags and values that you can use blockchains with. So now what we have is a owner. Let's say no one owns the protocol itself, right? It's the people get to use this protocol, and they can now send financial messages just like a financial institution, except not to a bank or an exchange, but person to person. So if those people, if you look at the top, it's you got merchants, producers, and consumers. So a person can buy and sell. In this case, they'd be a merchant. A producer would buy from merchant materials, for example, to give to consumers more whatever they decide to produce, and consumers would purchase, let's say, I mean, just even accept information in a financial nature. So this is just one example of an autonomous system that you can build up on the Safe network. So what else can we do on the Safe network? You can have a search. You can search research, scientific research. These systems, these computers, the way, maybe I should go back and give it a quick overview. You have a computer system, right? A whole group of computers that are interconnected with Safe network software. And that Safe network software connects all those computers together and sends messages back and forth between them, validating their existence and validating that they are credible entities connected. So when you use this network, you can request data that was already put. You can spend what's called a Safe coin to put that data, and then anyone can access that data if you make it available to everyone. So that being said, if you're driving a car and your car has a computer in it, it could run Safe network client, and that Safe network client could be driving with a GPS tracker, and that GPS tracker can be feeding the Safe network its coordinates, and you have the road being mapped in real time. So now cars can have knowledge, and you can make that knowledge available to any person on the planet, for example, like that. You could have buoys in the ocean collecting data about global climate change, and those buoys would take that data, put it into the Safe network for anyone to purchase or to give it away for free if someone wanted to do something like that. It's a tremendous amount of work has been being done to make this system possible. So imagine like, yeah, we're here about Bitcoin, right? And Bitcoin is like a currency, right? So you can trade Bitcoins, you can send them. That's just a payment processor. So one sliver of the Safe network is a payment processor. And then the infinite number of things else that you can do with it, they are available at the get-go because any type is readily accepted by this network, and that type can be redeemed by any person. So you can get any piece of data that was originated on that network. So just wanted to recap, since I'm giving an update on behalf of the MaidSafe team in Troon. Just want to thank the MaidSafe.org. Fergish, glad to see you. Thanks to David Irvine, to Nick Lambert, Paige Peterson, especially Bradley Rotter, especially Jason King, the one from China, Jenny King, Ward Rotter, the Lee Clagett, the whole entire MaidSafe development team. It's been very amazing. I mean, the things that are not yet released that are underway, for example, David looked into a new way of doing things with the network. So there's a language that's developed, and that language is about 5 times faster than C++. Not only is it faster fundamentally, like the way it works is development time is that much faster. It's actually like 100 times faster. Like it took 10 months to get to where we're at now, and in 1 month, David Irvine can rewrite the entire code into this new language in about a month. So that means our development time is like 20-fold, something like this, considering. So so that being said, we have an imminent launch, and this network is in fact like, you have distributed hash tables, so the way you get into the network, yeah, that's interesting, right? But what you do once you're in that network, now this is where the entire mind and universe can expand. I mean, sharing medical research instantaneously. You can, on top of that, there's the self-rewarding mechanism. So people, you gotta get funded by some university. They fund your research, and then you put it into a storage container, and that storage container, costs thousands of dollars to store what data no one ever uses usually, because you have to pay thousands of dollars to access it. Imagine that stuff can be accessed for $1, and that person who developed it still gets 3,000 because 3,000 people use it. You see, so we kind of solve so many issues we can evolve from this place, from where we are now, because the internet that we're using from the past is built on, like servers like that big, and you need like some kind of PhD to maintain that thing. So actually, like, I don't know, like, yeah, infinity algorithms, like, and then Project Safe, right? So without Project Safe, there's no infinity algorithms, but humanity can't really evolve because we're still using like this old technology from like 1950s. Let's move on from that. Thank you.